Section 1-6, solving compound inequalities.
Vocabulary. Compound inequality consists of two inequalities joined by the word and or the word or. Intersection. The graph of a compound inequality containing and. Union. The graph of a compound inequality containing or.
Symbols. And, or a compound, that little aggregator sign that equals the less than or equal to, and then the or compound, you have the aggregator, and it's pointing away from the symbol, and that would be less than.
Key concepts. And compound inequality containing the word and is true if and only if both inequalities are true. Or compound inequality containing the word or is true if one or more of the inequalities is true. Helpful hint. And has to satisfy both and or has to satisfy at least one or both. Visual demonstration.
Compound inequalities. There are two types of compound inequalities. The first type is the type where inequality has three sections separated by two inequality symbols. The second is the or type, where there are two inequalities separated by the word or. Let's look at the and type first, with the variables in the middle. We can solve this two different ways. We can separate the three elements into two separate inequalities, then graph them both and see what happens on a number line. Or we can solve the three expressions simultaneously, giving us the unknown in the middle as we finish. And here we show that the first step of this method, subtracting 7 from all three expressions, the one on the left, the one in the middle, and the one on the right. I will call this method the three-headed monster method just because it's getting close to Halloween and I think it's fun to think about. Now, in the middle, the 7 minus 7 cancels. We bring everything else down, so we have 6 is less than 2x, which is less than or greater to 10. We need to divide everything by the coefficient of x to get x isolated, so we divide everything by 2. The 2 over 2 in the middle cancel, and we bring down what's left. 3 is less than x, which is less than or equal to 5. Now we have our two boundary points. Let's see where they fit on the number line. The boundary point on the left is an open circle for less than, and the boundary point on the right is solid because of the equal to characteristics. Then we fill in the place on the line between the two boundary points. The and compound inequalities will have the distance between boundary points filled in. Let's look at this or compound inequality. It really is two separate problems that will be graphed on a single number line or even on a coordinate plane. To solve the left one first, we add 2 to both sides, and we cancel on the left, so we bring down the result, and that would be y is greater than -1. To work the problem on the right, we subtract 4 from both sides. We cancel 4 minus 4 on the left side, and we bring down the result, which is y is less than or equal to -7. Now we go to our number line. The open boundary point goes here at -1, and since the symbol is greater than, we draw the arrow to the right, meaning that it goes on infinitely to the right. For the other problem of the or, we first draw the solid point at -7, and since the symbol is to the left, we draw the arrow to the left. And so this is what the or looks like, and it's with arrows going in opposite directions, so that's a key characteristic. This compound inequality can also be graphed on a coordinate